So welcome to the next SimFix seminar, everyone. Today we've got Rowan Cockett with us. Sorry. He is one of the founding members of SimFix and the whole organization there. So we're excited to have him on here, hear what he's up to right now. You've been working on Curve Note for the last 2 years or so, 2 years plus, getting that up and going. So sure we'll probably learn a little bit more about that and see what your thoughts are. But I would say take it away, Rowan.
Awesome. Thanks so much. So I'm gonna talk today about a massively big topic and a very small parts of this topic of sort of the future of research, communication, and collaboration. And I'm gonna sort of introduce some of the perspectives and observations that I've made, as well as pull a lot on the Force 11, that they have some principles, and they're sort of this organization of scholars and librarians and people who are working in scientific publishing who have come up with all sorts of principles for this space. And so I'll sort of walk through some of those as well today. And then I'll finish off with sort of a few demos of the tools that we've been developing for communicating and collaborating on science in the context of sort of those wider goals. Awesome. Okay, so science communication. I think when we look at sort of the challenges that are facing humanity, these are like globally relevant and really urgent challenges: climate change, pandemic, water security, that really require us to rethink how we as scientists are sharing, communicating, and collaborating on scientific breakthroughs. And I think maybe a near-term example of this is really the massive changes that were happening in COVID when that was happening, and medical journals really had to change their entire speed, and the adoption of preprints was just sort of transformative to the bio space. And this is something that's been happening for a long time. There's like 40-year or 60-year history of archive and all sorts of preprint and open access sharing. And I think a lot of these are starting to hit the mainstream sort of public perception of how science is communicated. So this is an example from The Guardian last week of should we get rid of the scientific paper, and really talking about a lot of these challenges of scientific communication and sort of how they impact greater society. And so I'm gonna take some pieces of this and sort of look back over how scientific communication specifically has evolved as I've sort of seen it happen. And so if we look at sort of the traditional publishing system, there's a sort of, as science is conducted, there's the definition of a problem, maybe designing a study, collecting some data, analyzing that data, interpreting it. And then the communication of that in sort of the traditional publishing system is going through a peer review process and sharing that behind a paywall. And this sort of the who we're communicating to in this system is other scientists in institutions that pay for that access. And so general citizens who want access to this. So for example, the Watson and Crick paper about the structure of DNA is a $32 charge if you want to gain access to that legally. And so this is something that is being worked on throughout a number of different fields about sort of this open science and open access movement of science, of really bringing that sharing process and communication process a little bit earlier through preprints, and then also changing who can access that science. And really open science is sort of this critical accelerator for the UN Sustainable development goals. So hunger, poverty, climate action, and really making sure that that is an underpinning of that. And so I have an example from Santiago, who's on the call today as well, and that's sort of this movement towards open access through sharing of preprints. And if we look at sort of the what of what we're communicating, I think it's also changing quite substantially. Is it's not just the PDF at sort of the end of this large amount of work. It's also the data and the figures underneath this that are archived and through data repositories like Zenodo or Figshare. And so there's a lot of work over the last decade, especially of improving that support for archiving. But I think especially these two examples even of screenshots of Earth Archive and Figshare, the communication of these still could use a lot of work in terms of, if you look at the Figshare site, there's all of this work that's gone in here and has been archived, but the actual communication of that, it's still very difficult to sort of browse and see it. And the other change that I'm seeing in sort of the communication of science is moving towards more interactive results. And so that's something that we've done a lot of work on in the geoscience community, which is sort of SimPeg adjacent, with educational resources that are fully computational, where you can put these into the hands of students, where they can start to play with the interpretation and analysis of data and sort of start to get a handle on these sort of upstream aspects of communicating science. Another journal that's sort of really a front runner and pushing the boundary in this field is DistillPub, which is a machine learning journal that is really having all sorts of interactive ways to explore scientific results. And that's bringing that interactivity in, it's bringing computation into the way that we're communicating, and it's really making that work more reproducible and exposing that interpretation and interrogation to the end reader. And I think as sort of zooming out of the system, really the communication is starting to move much more upstream, seeing those interpretation through interactive pieces, moving the sharing up so that you publish it right away through preprints. There's pre-registration pieces where folks, especially in biology, are registering the problems that they're going after. Micro publications are starting to break up the different pieces of this so that you can publish different parts of your work as you're going. And of course, preprints are a big part of this, data and software citation. I think some other components of this are really, there's aspects of sort of informal scientific communication that are throughout this entire process. So documentation, the open meetings, for example, that SimPeg is a big proponent of, and seminars like these of really bringing that communication as you're doing the work, and it's in progress. And so this sort of idea of bringing that communication as you're actually doing the science, sort of one of the analogies I'd like to draw on here is the analogy to open source. And so the open access movement is something that's sort of going through the same sorts of things in terms of licensing and open content that the open source movement went through in science. And there's similar pieces in terms of bringing when you release software has analogies to when you release scientific results. And there's been a ton of studies in development practices of moving from waterfall, where you release at the end of a scientific study, towards more agile and continuous practices, where you're releasing as you're going, you're getting feedback, in their case from the customer, in the scientist case from other scientists through peer review. And in those circumstances, the speed at which folks are releasing software is 46 times, comparing the sort of waterfall practices towards continuous delivery practices. And I think the really interesting part of that is actually the change failure rate, the amount of rigor in this process, because you're moving faster, is actually 7 times less. And so there's this really interesting trade-off of the ability to actually move way faster, but also way more rigorously. And so I think this is something that, as we're sort of moving towards these communication practices, that's I think some interesting analogs to draw. And so I want to sort of highlight some of the recommendations from this Force 11 group, which is, and so that's the Future of Research, Communication, and E-Scholarship. And it's a community of scholars, librarians, activists, publishers, and funders who are facilitating change towards improved knowledge creation and sharing. And this manifesto is actually a fantastic document of sort of trying to capture the state of research communication and offering some guideposts to improve it. And some of them that I'll talk about, and I've sort of hinted to here, are rethinking the unit and form of scholarly publication. And so in terms of the unit, that's how are you making it smaller and more modular through micro publications? And the form, how is it more interactive, more reproducible, and getting more towards networked science rather than emulating a static piece of paper that we're putting on behind an iframe. The second recommendation that they have is really developing tools and technologies that support that entire scholarly life cycle. So all the way through, and sort of having infrastructure that really supports scientists and their communication practices throughout that process. And then this third piece is really focusing on the data and software and workflows and making those part of first-class research objects. And so I want to talk about some of the work that that both the executable books community is doing through MIST, which I'm a part of, as well as the company that I'm working on called CurveNote, and really framing these in the process of these sort of principles and objectives that the Force 11 community has put together. And so the first piece is thinking about the unit and form of how communication is done. And so I'm going to jump over to a demonstration of CurveNote, of being able to think about the figures and graphs as sort of independent scholarly objects that can be referred to, cited, commented, have version control on them, have licensing and attribution, such that you can use and reuse those throughout computational notebooks, presentations, textbooks, and articles. And I'll show that by starting in this writing environment. So this is CurveNote, and it's a writing environment that's designed for scientific work. So there's pieces like citations, for example, that you can directly pull from a BibTeX file that's attached to this project. There's support for equations that can be referenced and referred to, and a lot of the thought that is going into this work is really around making sure that all of the work that scientists are doing is actually this isn't a text-only citation. This is a reference to that literature, and it's semantically accessible and programmatically accessible. And the other component here is the ability to embed these sort of rich interactive artifacts that come from a Jupyter notebook environment. And so that can be through sort of 2D pieces or 3D maps and interactivity. And so what I'd like to show now is sort of the connection between these different forms of where you're working. And so I'll jump over into a Jupyter notebook and show sort of how this sort of unit is connected between the different forms that it's presented in. And so this is a Jupyter notebook that has some data analysis in it. I should have probably put together a SimPeg example here. But this is an Altair plot. It's interactive. We can save that to the curve note system at this stage. So this on the right-hand side is some of the capabilities that curve note adds to a standard Jupyter notebook. And it adds that sort of collaboration and version control. And you can see that the version control is on the output. And so I can actually copy a link to this unit of scholarly work and bring it into the report that we're writing. Sorry, I'm just going to refresh. And if I now just actually paste that in, so that's a Command V, then that's that chart sort of comes directly in here. And I think one of the exciting pieces about really thinking about these as distinct scholarly artifacts is that they can have version control and collaboration and attribution baked directly into those pieces. And so I can have some comments that come in here. I can see the version history of this object, and that comment and version is shared wherever that is used. And so that can be over in the Jupyter notebook. And we can, for example, make some changes to that, hit save again, and this is all sort of linked together. And so coming back over into the introduction, we can say use the latest, and that will bring the latest version directly in to the Jupyter notebook. And so this is aiming to really support that a little bit of that change towards much more granular access to scholarly work. And the next piece of sort of supporting this life cycle of communication is one of the pieces that we're focusing on at the moment, is really focusing on being able to communicate and have professional publications of your work that you're still in control of. And so I'll maybe go through a few of these. So one of the pieces that I went through is I wrote a PhD thesis. And so that has all sorts of various components in it. And having the way to communicate this, which is much more sort of interactive and accessible through mobile devices, and be able to skim and send someone a link directly to a section of the thesis, is really something that I've had challenges with in terms of when I'm trying to share some portion of this 250-page document. And that's a very similar feeling that we've gotten when we've been working with some climate scientists and soil scientists who are trying to communicate both to non-scientific stakeholders like farmers, as well as satisfy their grant requirements, which is to submit a 250-page PDF document. And so this is something that we've been working with these folks in terms of trying to get their work into a form that both has more of the supplemental material, like the notebooks that are behind a piece of work, as well as the sort of all of the work that is there. And so that's a few of these. I think there's a a couple other components of scientific communication. The SIMPEG seminar site, for example, is something that's over the last couple weeks, we've been working with Lindsay and Soggy on really bringing over and showing off the SIMPEG documentation that sort of elevates these weekly or monthly conversations into something that can be interrogated and seen by a number of other people, and hopefully in the future cited as scientific communication artifacts. And then the final piece that I'll show in this section is a conference that we're working with and sponsoring, called the Software Underground Transform Conference. And this is something that's actually happening next week. And we've gone back through all of the various tutorials that are scattered across GitHub that have just an amazing amount of fantastic content that is often sits in a GitHub repository and really doesn't have that aspect of the communication that is required to be able to browse and collate and bring it together in sort of one of these standardized ways. And so this is a conference that's happening next week, and I think probably some folks on the call are involved in. So super excited to be able to support some of this. And then the final piece that I want to talk about today and give a bit of a demo on is how this all sort of fits together and works with data and software that folks are already using. And so that's primarily through Jupyter notebooks. And so I'm going to go through a bit of a demo, and I'm going to be starting with some CurveNote content, and then showing how this gets from CurveNote into your local machine, working on it in that environment, and then being able to publish that to the web. And so I have at this stage a terminal open, and I'm going to say CurveNote init, and that is going to ask me a couple questions. So this walks through and helps create a structured directory on your computer that both syncs content to and from CurveNote. And so that's sort of speaking to two different personas of some folks who are comfortable with command line interfaces and Git and Markdown, and then some folks who want to be able to collaborate online with what you see is what you get, Word or Google Docs like editors. It also allows you to build and export PDF or Word documents and create a website, which I'll sort of go through today. And so we'll just give this a name. And this research example is actually of a recent eruption in September last year in Tenerife at La Palma Island, which was off of the African coast, part of Spain. And this is a small paper that sort of looks at the different magma chambers and plots up some time series events of the earthquakes that are happening that support that sort of hypothesis that there are two magma chambers that are happening. And so this asks me to copy a link to this. And so I'll just copy that URL and say import from CurveNote, paste it in there. Ask me which folder locally to copy to. And then if I want to start the web server now, and I'm going to say yes to that. And so that will both pull the content and bring it locally, as well as start up a local web server in a few seconds. So you can see that it's built all of these sort of notebooks after it's pulled it down, written some config files and built that. And then there's a local website that is able to sort of show that directly. And so here, there's all sorts of IPython notebooks that have data analysis with them. And I'm gonna just show you what that looks like inside of a VS Code environment. And so what this pulled was all of the content that is on that curve note document. And so we have a paper which has all sorts of metadata that has been added from working through the curve note user interface, as well as these linked blocks of information that have some version control associated with them, types of tables. And some of you might recognize this as mist markdown. And so that's a new, a relatively new initiative out of the executable books community, which is behind JupyterBook. And this format that I'm showing here is exactly the same as JupyterBook. So there's compatibility there such that you can bring that content and sync it backwards and forwards to your local machine. And I will show you the editing experience just very briefly when you're in sort of a local environment. And so once I'm in there, I can say curve note start, and that again just brings up this this local server, and we can go back over to the main article, which this is the document that I'm working on over here, and you can sort of see in September 2021, and we can make some changes over here, hit save, and if the demo gods are with me, which I think they are not, because I have a separate web server on the same socket. Anyways, that should be a real-time update. So when you hit save, there's about a 20-second delay or 20 millisecond delay, and it will show you all of your changes there. And so I'm gonna change that back, and then I have to refresh again. And then I want to, so this is actually all local right now. And so one of the next steps in here is really communicating out to colleagues and to the wider audience on the internet. And so the command that we have for that is to actually deploy this to a website that CurveNote helps host and helps archive the communication artifacts. And so when you hit CurveNote deploy, that rebuilds the content and it uploads to a staging service. And then in a few seconds, it should give us a link which we can share. And so this rowanc1.curve.space is now live. And this has the article that we were working on that is published in this sort of professional way that can be shared to other scientists. And it also supports all of the sort of interactive features of Jupyter Notebooks, and Altair, for example, I think is one of the examples. But hopefully, there it goes. And so this is something that is actively in progress at CurveNote, and something that we're extremely excited about sort of lowering that barrier to entry of sharing computational scientific content in many different forms to really support the different life cycle and artifacts that are in the ways that that folks are communicating more and more, as well as supporting that data and software and computation directly in the way that we're communicating science. So that's this is a bit of a recap of sort of the types of efforts that are behind CurveNote, of really trying to rethink that unit and form of scholarly publication. And it's much smaller. It's the figure, it's the equation, it's the paragraph of text, and developing these tools and technologies that support the entire scholarly life cycle of how we're working to how we're sharing and computation, and making sure that that's aligned with community practices that are governed by community stakeholders in the executable books community, for example. And a big part of executable books is really supporting Jupyter artifacts, which include data and software and the workflows that are in all sorts of computational sciences. So with that, thank you very much. A lot of my work over the last couple of weeks is supporting the Swung Transform conference, and that's happening next week. And there's going to be a ton of amazing geoscience conference material and tutorials there, learning Python, learning Julia, and we're happy to host and sort of give that work a little bit of a wider audience. There's, of course, the MIST and executable books community at executablebooks.org. And if you want to learn more about anything CurveNote related or MIST related, I'm happy to chat. Awesome. And I would love to have some questions.
Yeah, thanks, Rowan. It was nice to see what all those processes coming together like that. Again, if anyone has any questions, go ahead. I see you unmuted yourself there, Dom. Were you thinking about something?
Good. I was testing my my inline mic. Yeah, so like the old model you're trying to disrupt there again, eh? So the old model, the publishing company was obviously getting a fee, right? And like you know, everything upstream of the publisher is free. Like people are, you know, working and doing all the peer review and stuff, and then they hit the paywall, right, of publishers. But they were offering some service, right, in terms of like having like editors and like a house where, you know, people know where the information comes from. So do you think the open source can do it all on its own without charging anything? How do you foresee the charging structure? Because obviously people are going to put time to, you know, put this stuff together and maintain the servers that you're going to be running off and all that stuff, right?
Yeah. So like looking sort of at the, there's been sort of a movement of charging for the content itself, to charging sort of this article processing charge, which is at the time of publication, where you're paying to publish with a journal or society. And I think the trends that we're going to see is more towards these services that are offered, that are either archiving, that are supported by institutions and like societies or universities that are offering compute services, data archiving services, communication services, and possibly some of the types of tools that I was sort of showing today. Is supporting and maintaining that infrastructure is a massive amount of work, and it's work that scientists or the open source community, it needs to be supported by the institutions that are sort of paying for science. And so if I'm looking at types of charges that say if you're paying like article processing charges range anywhere from like, well, zero, but sort of around $500 to Nature has a $10,000 or $12,000 fee. And so I think those pieces, if they're aligned towards the incentives of how do we improve scientific communication at all stages of the life cycle, rather than just at the end of the life cycle, there's a much more alignment between those business practices and sort of the ways that scientists are working. And I think there's something more akin to how GitHub interfaces with the open source community. As GitHub gets better, software development practices and collaboration practices get better. And so I think it's really about aligning any sort of incentives from the business side with the processes of doing science.
Yeah, it's fair enough. I didn't think about that. It's true. Institutions, they actually pay a ton of money to journals, right, to get access. So they could divert those funds. I mean, you're not gonna make yourself friends with nature, but but yeah, it's a good point. It's a paradigm shift.
Phil, I see your hand up. Got a question?
Yeah, so it's kind of the same topic. I'm just wondering, for a concrete example, the Wachtingen report. So you're going to turn that over to them, and then are they going to try and self-host a web version of that themselves, or are they just going to be happy with the PDF, or how is that particular instance going to work?
With the climate change report that I
The
showed?
soil, yeah, the soil thing.
So in that case, the requirements from I'm blanking on the name of the institution are at this stage just a 250-page report PDF that is deposited in their archive. And so we're working with the individual scientists who wanted to do a better job of communicating to their stakeholders. And so in our case, that's a process that we're going through and sort of working on improving communication, and hoping eventually we'll get to those institutions who see that and want to invest in that sort of communication infrastructure.
And just, for that deploy example you just gave, so that's actually then sending static pages to Amazon or someplace on nodes that you host that are running a web server like Apache, is that? And then you have a charge that actually covers your costs on that plus some margin?
We will work something out on that side. So this is, I think, where our business model will be, is there be some sort of free access that you can post to a curve.space domain. And if you want to host, say, a conference, for example, using this infrastructure, that's a slightly different engagement that requires talking to us. Or if you want to bring that over into your personal domain, similar to how a WordPress model works right now, is you paying like $12 a month to host your own material and have a service behind the scenes that helps you write and communicate science.
And then in terms of moving, suppose they wanted to actually move from CurveNote to JupyterBook. Yep. Is it just vanilla Mist then with your own it's special metadata that actually is handling kind of the cross references, or how much of it is actually your value add versus JupyterBook?
Yeah, I think the value adds that we will continue to focus on are being able to have a password protected page if you want to share this with a supervisor online. That's something that likely JupyterBook isn't going to focus on. In terms of the compatibility with JupyterBook, over the past 2 months, half of my team has been working on the Mist specification and making sure that actually is a solid thing to build upon, such that we have full compatibility with the executable books ecosystem.
Yeah, really impressive.
Yeah, Rowan, I had a thought or question. So I did a project recently where I was using Rise to turn the Jupyter notebooks into like living presentations, right? Do you have any thoughts on like kind of that sort of system, or at least supporting that kind of work with CurveNote or anything like that?
Yeah, I think presentations are something that I've been wanting to get to for like a year, and that's certainly is on our roadmap to be able to support those pieces. I think that same sort of copy, paste, and importing of interactive, referenceable content is something that is definitely something we're excited about.
So currently, Curve Node, Rowan, you are not you're not employed to convert files or to basically make the Curve Node documents that is publishable. It's kind of like the user that has to learn the infrastructure and then do it themselves, correct?
Yeah.
Okay.
Right. And I certainly hope that the types of tools, like in the executable books area, that these are open tools that scientists can adopt, that have communities, many different communities and stakeholders behind them, that there's this next wave of like on from, say, LaTeX into these sort of more web native ways of communicating science, and sort of designing technical markup languages that are directly for the internet age, where you have these references and cross references that can pull on information or be published in different ways. That a lot of the work that publishers currently do is they get submitted a Word document with a text block at the end of it that has references, and their value add is turning those into like real references that have DOIs and all of the appropriate metadata attached to that. And I think there's a lot of value that can be brought to scientists as they're working if that metadata and those processes are actually available directly at the time of creation.
That's true, but there's also, you could argue that most people the vast majority of people are nowhere near that level of skill, right, to be able to do it. But there could be a business model, right, just to be, let's say people they really like the product, the live product. You could become an editing company that just does that, right?
Yeah, and that's certainly on the Climasoma example, the soil climate change book that was like 250 pages. We were in the background trying to make everything work for them.
Sure.
And so
you don't make money then when you do that, but
yeah. So it's figuring out how to make that scalable and have the appropriate like user interfaces that make that very easy for scientists to do themselves. Yeah.
I was just thinking, Craig Hart, I don't know if you're still on the call, but I was thinking, looking at this at the 43101 reports, right? All the miners that have to publish PDFs, and they often want to try to use them as promotional value, but it's terrible, right? It's non-standardized. It's somewhat standardized, but it's not really user friendly. If you could turn those into like through something like Curve Note, something promotional.
Yeah, I'm here, and that's a great idea, and you're right. The intention was that everything would be open and transparent and accessible and everything like that, but because there was no standardizations for any reporting or even countrywide, between for assessment reports between the different provinces and territories, there is not a thing standard, and everything is just in languishing in PDFs, and so it's a real missed opportunity. So something like this would be great.
Yeah, I mean, it is standard in a way, right? Like the heading and everything, they have to file those, but in terms of format, it's all over the place. And these guys are definitely, we need editors because they're not programmers, but yeah. Could be a business there.
And I think it was to the point where the the format doesn't really allow you to put data in, and people tried to do that, and then they discouraged people from doing it because it just made these files, huge PDFs, and what are you going to do with that? And so the movement has been to not include data, which is absolutely the wrong thing to do because you're trying to provide transparency and justification in a data-rich environment. So yeah, it's not gone the right way.
Yeah, I think that's the one thing that I also worry about of the move towards preprints. I think there's also a move towards the PDF being the final piece and trying to shove as much in there as possible, and sort of a similar challenge to what Craig you were saying of discouraging tables and tables of data that are in the PDF, and then suddenly that's disconnected in a different archive somewhere, if at all, and it's really difficult as someone who's coming in and sort of trying to navigate what has actually been published and what was actually there.
So going back to the gatekeeping part of things, one thing that happened during COVID, right, was that a couple preprints on ivermectin, for example, by rogue MDs actually got amplified through Facebook algorithms, right, and all of a sudden had enormous weight. And so what do you think, I mean, what's the solution to that problem?
Other than like getting rid of Facebook, is that is like a more realistic one? I don't know. I think that I suppose where I see just a ton of value is the types of communities like this Simbag community and the software underground community, where you have scholars who are getting together in those ways and improving the communication practices on them. I suppose like that's like where I'm trying to focus, and I think there will absolutely have to be, I don't know, other ways, but that's, yeah, no, I don't have a good answer for bad actors.
It's a little bit like how Wikipedia works too, though, right? I mean, obviously, it's not a real scientific place, but over time, if there's enough users, then the bad actors they get swamped, and they just get ranked down, and you don't really see their stuff, right?
Yep. Yeah,
could be the solution.
Yeah, I think internally to these communities, I think there can be very good curation practices. I think the challenge is when one of those pieces of information leaves that and spreads in a totally different medium like Twitter or Facebook. But yeah, no, but these are massive questions.
Yeah. Why don't you solve it, Rowan? Solve it better.
Attacking a small piece. Yeah.
Any other questions or topics people would like to discuss or anything?
Hey,
Yeah, so Force 11, I had never heard of that before. What's their like end game, or I mean, are they growing or shrinking, or they've been around for a decade now, I guess, right?
Yeah.
So how do they see their role in this whole thing?
I think they have an enormous amount of weight, especially in the bioscience community. A lot of the initial people who were at that sort of like founding meeting in 2011, they were like heads of NSF and NIH, as well as in Europe. And so a lot of the pieces that they've put in place are sort of around where the funding goes, and that there needs to be open access components to papers or data. And so that's I think a lot of the systematic work that's being done and helping sort of facilitate through that organization. The FAIR principles, which you've probably heard of, came out of a working group out of Force 11, and there's all sorts of other software data principles that are coming out there. So I think that's sort of how they see their work and role in the community, is bringing people together through working groups, having these guiding documents and influencing at the regulatory level.
So are they the reason that NIH moved to require open access publication? Is that?
I don't know the full story behind that. I do know that some of the people there were in those same rooms.
Santi, I think you're about to speak up there for a second.
Yeah, I just wanted to say that I think one of the last time I gave some feedback on Kernel, I was saying that I would love to see a command line interface for it. So kudos for that, because yeah, you got me there.
Almost there.
So I was going through the documentation, so you can install it through npm, right?
Yeah.
Is there a plan for Conda Forge?
Yes.
Awesome.
Yeah. Yeah. So we will mask it like it's a Python repository, even though it's not. And so it will be sort of the same as installing Jupyter and have the same requirements as that. And so if you're familiar with Python tools, hopefully it's not too different.
Nice. Awesome. And yeah, and one question, two questions. So you could download with the CLI, you can download any public curve node project for, yeah, okay. And you get the full source, right? You can do whatever you want with that. I mean, not only just a LaTeX version or just a PDF.
Yeah. Yeah, the sort of native, in quotes, format that we're aiming for is MIST Markdown and sort of the structure there. And so that's what we'll be aiming to support over time.
Awesome.
And that, I don't know, there's work to bring MIST Markdown editors directly into the Jupyter Lab interface to sort of make that editing experience smooth as well.
Yeah, that's great. And I saw that you can put like the images with some hashes. Is that easy to do locally, or you have to go through the web interface?
There's a lot of holes still in the command line tools, and there's certainly especially with our integrations towards like Git and GitHub, I think that's a big part of what we still need to figure out. And so there's some workflows that work really well, but those are primarily around Jupyter notebook workflows. But some of the other off that path are still a bit shaky.
Great. Okay. Yeah, looking forward to see that growing. And I would be very glad to write like a new Vim plugin for KubeNode, something like that in the future.
That would be exciting. And part of how we're also trying to work is make sure that those plugins are also accessible in the Jupyter book ecosystem, so that sort of that underlying infrastructure is completely open and you can take your content wherever you want.
Sure. Yeah, thank you very much.
Okay, well, nothing else. I think it's probably coming up in an hour here. I don't want to keep people too long. Unless you're, I mean, I'm happy to stay on, but anyway, thank you guys all for coming to the Syntax seminar.
Yeah, no, it was great. Good to
Thanks, Rowan.
see you all, and thanks very much for the questions.
Take care. Hope to see you guys all at the Software Underground conference next week.
Yeah, totally.
Take care.